We're live. We did it. Oh, wait, the music's still. There we go. I got the background blurred because I don't want people in the landscape, and I got us in the foreground. I got AI isolating our voice. We can have like an actual conversation here live in the middle of a very packed conference. I'm with Thomas. How you doing, man?
I'm doing good. I'm going really cool. I'm like just coming from the panel with the native image on the native image panel with
Right.
other framework authors. Also, a lot of people from the Spring team there.
Yeah.
And
You had Sebastian on it, I think, as well.
yeah,
Right?
yeah, Sebastian was on the panel.
Our Sebastian Deleuze, who's been on the show before, of course. I mean, you are very much in demand. Especially, I mean, everybody knows who you are right now. The GraalVM is.
Well, at least everybody knows what GraalVM is nowadays, and we are super happy to have people on the conference, both from Red Hat, Microsoft is talking about GraalVM.
Wow.
And also Spring team is talking about GraalVM. So we love it, and because that's a validation for our technology. Like, if we go out and say, GraalVM is great, that's, we are the authors of it. So like,
right.
It's like people are not necessarily gonna believe us.
Right.
But if somebody from another company goes out there and says, yeah, that thing kind of makes sense and can do good stuff.
So freaking fantastically good that I have to, if I just said that all the time, people would think I'm like smoking something or something. So I have to like take jokes. I have to make jokes.
Right.
Just to temper it so people understand, yeah, nothing is perfect, but pretty great. Pretty freaking great. Right. I'm a huge fan. And that's not just a
that's super great to hear, Josh. And I mean, there's many reasons why one could be a fan of GraalVM, and one of the things actually is on GraalVM is the sustainability aspect of using less energy for running your code, right?
Right, which is a huge deal. And I also talk about that in my talks. I also make a little joke about there's that old chart from 20 there's a paper looking at energy usage across different languages, and Java's in the top 5. So already Java doing quite well. But then you get GraalVM, and the at the bottom of that chart, the very bottom of that chart was Perl, of course, and then the penultimate one was Python.
Right.
Oh, it was like 35 times more inefficient than the equivalent Java program.
Right. Yeah, absolutely. If you have a lot of Python code, it's like just takes so much to add an integer in Python. And in Java, it's much faster, and with native image, you get it even down more.
Wow.
And yeah, there's been a recent study actually by an external researcher on the most energy efficient VM for Java.
I saw GraalVM,
and it was GraalVM native image. Yeah.
Right. Yeah. And so Java itself is great. I think the GraalVM JRE thing was also in the top of that.
Yes. The JRE, the JIT version of GraalVM was also up there, right? But then when you go EOT, it's even further, because when you execute a Java application, you really don't want to run the JIT compiler on each startup.
No.
It's like, and it's doing the same thing all over again anyway.
Yeah.
Because it's like it will start with compiling string hash code, which is a very common method.
Right.
And it will do the same thing every time you start an app. And with GraalVM, we are not doing that.
Yeah.
We are doing it once.
Just once.
And
nobody pays
so much effort. It saves so much effort and energy, and that's why GraalVM can, there's so many Java deployments out there.
Yeah.
If they're running on GraalVM, we're saving so many CPU cycles that are currently wasted on Java programs.
Right.
Creating the Java long integer cache. So
skip that work.
Yeah. Exactly.
So this kind of stuff. Okay. Yeah, you're definitely very, very much in demand right now. I can see as we were walking by, people are like, oh, hey, it's you. And I get it. Just obviously a very busy day for you. So the reason is because you created it, right? You were the, again, I always ask this question, why did you do that instead of take a nap or something? Why spend so much time going down that rabbit hole?
Yeah, it's interesting. It was a very long time ago when we started this as a research project. It was like,
so you didn't get famous overnight. It
was 12 years ago when we were starting GraalVM as a research project, and we were a super small team. And I was then joining Oracle, and I had a background working for Google on JavaScript VMs. And before
V8
exactly, V8 JavaScript VM, and before I worked on Hotspot for some microsystems and the C1 compiler.
Mm-hmm.
And so I worked on VMs for Java and JavaScript, and I thought, well, why don't we do just one VM for all languages? Because in the end, some of the technology is kind of similar. Of course, the Java ecosystem has been blessed with actually the best VM technology.
Mm-hmm.
Because Hotspot has been created very early in the Java days, But in general, still there could be some reuse. And that was the original idea behind the GraalVM project, to create like one compiler for many different languages, and we called it like one VM to rule them all.
Yeah.
So a research paper. It's very funny. Very funny to read that nowadays.
You got a Lord of the Rings reference into a research
paper.
Okay.
That's right. That's right.
Already have my respect.
Yeah, that was the original thing. But then, I mean, nowadays GraalVM is more known for native image stuff, right?
So the thing you're talking about is the truffle.
Yeah, it's the truffle and the polyglot
Right.
things, because GraalVM, and this is something nowadays people associate GraalVM primarily with native image. There is still some things that we can do. We can execute JavaScript. You can execute Python. And, specifically on Python, we will over the next couple of releases publish more on this, because we feel like from Java, using Python ecosystem could be quite interesting as well. Like if you have a Java application and you want to have your Spring libraries, but at the same time, for one part of it, you might want to use a Python library.
Yeah.
And GraalVM actually allows you to do that. And this is less known, but this is completely unrelated sort of to native image.
So I've done many a presentation with Alina Urenko. You're one of your star advocates.
Right, yes.
But I also was I read one of Oleg's Oleg Shelejev's blogs years ago, and he talked about using R functions from within a Spring app. I was like,
yes. We can also do R. R is another thing. We also do Ruby.
Right.
And it's an interesting, for certain use cases, it's very interesting. We think that specifically Python from Java could be superior.
Yeah.
And then we have Alina Dev Advocate, and over time, but this is very important. Like, I mean, there's a couple faces of GraalVM on Twitter and social media, but like over time, like since we started it, 12 years ago, the team has grown really, really big.
Good.
And we have many engineers behind who are like working on the project and doing kind of a lot of great engineering on it. So I really like to emphasize sort of, if you see a couple of faces of GraalVM, yes, those are the people who are responsible for getting GraalVM known.
Of course.
Right. But like it's really important that like there's actually a very, very large engineering team behind it.
Well, that's why you're here.
And
and also people who've had the dubious pleasure of seeing one of my talks will probably recall that my favorite GitHub thread ever with Fabio Niephaus. That again, great team, great sense of humor. I love it. Huge effort, obviously, and internally and open source, right? Like
it's internal and open source. I mean, my team is on GitHub, like maintaining. We counted it once. It was about 4 million lines of code on GitHub that we are maintaining across all the GraalVM projects. The core is about 1 million lines of code, which is compiler native image, and you can see every day the commits streaming in and the PRs opening on GitHub. Like you really can see the activity and the different people working on the project quite well on that GitHub history. And we also have the JavaScript project and Ruby project extra. But in total, it's 4 million lines of code that we are maintaining on GitHub. So it's a really, really big effort.
Wait, so you okay? Maybe I just need more coffee. You worked on V8. You've got a truffle JavaScript.
Yes.
Is one at all based on the other, or is it just a brand new clean room?
It's a clean room. It's a clean room. Like Truffle was like the thing where we thought, okay, we have a Java compiler that can write Java. How can we make that one understand JavaScript? And then the Truffle layer is sort of the thing over the top, which prevent, like, our compiler continues to be language independent,
right?
And we are like doing the on top thing only with Truffle, right?
Yeah.
So this is the polyglot stuff, right? But then the question is, how did native image like come together, right? And it's sort of like it wasn't even the main product, GraalVM. It was like a side effect. And, and the thing was this, that like, we worked at Oracle, of course, and we wanted more funding, et cetera, et cetera. And what do you do if you want more funding at the company? You try to attach yourself to the flagship product of the company.
Right.
And at Oracle, this is Oracle database.
Sure.
And so we had the task of like, okay, why can't you run these languages in the Oracle database? Because it would be great to do stored procedures, that you have the option to do stored procedures also in JavaScript or Python, so other languages.
Yeah.
And this is when we were like developing native image as a way to get our Java compiler that's written in Java into the Oracle database, which is a native code, written in C, right? And native image was our tool to get our Java code into that thing. And that's why the original design point of native image really was targeting primarily just our Java code.
Right.
Which means like we did some shortcuts when we first came out, and so that's why it was then really like
So you weren't assuming the general purpose sort of,
No,
I want to run Hibernate or something
no,
like that.
absolutely not.
This is just, I have an optimized, I want to do a
Yeah.
store procedure in
That's
this
right.
framework that we control.
Yeah.
Okay.
Yeah,
enough.
absolutely not. We didn't assume anything to be generally usable.
Yeah.
And then we were really surprised when, we came out there and then people started to use it for Java web server applications. And they're like, oh, I can start a Java web server in 5 milliseconds.
Yeah.
That's great.
Yeah.
And we're like, oh, we didn't think about this use case.
Wow.
And that's when sort of we started to realize from the community perception, like how important native image was for the project. And that's why we are more and more focused now on making this part of the project really good. And this has shifted a lot in the last year.
And I trust now you don't have to shoehorn GraalVM in terms of the Oracle database at Oracle.
Right. No, and it actually the project to get GraalVM into Oracle database is very successful. It was shipping. It's shipping in 23C of Oracle database. So the technology is in use there as well. Because GraalVM in general, it's one of the big advantages as a VM it has, and this is real competitive advantage, is it's embeddable.
Yeah.
So you can take it and you can embed it into a C++ application, and there's certain aspects that we try to avoid to make that possible. Like for us, for example, using signal handlers is optional, right?
Right.
So in that sense, we really made the design point to be embeddable. And that's why we embedded in the Oracle database. We also embedded in the Oracle NetSuite product, which is an ERP system.
Oh, okay. Thank God you spared. I totally knew that. I was just going to test you.
It's an ERP system, and like this embeddability aspect is just
that's amazing. Okay, so you just talked about the embeddability. You also talked about native integration. One of these things I don't think really people appreciate is that you can actually create a .dlib or .dll or .so from your GraalVM compiled like Java app, I guess, right?
Yes, absolutely. You can take a Java app, create an SO file from it, and link it with the C program.
Or Go or
Rust, or Go program or Rust program.
Whatever.
Yeah.
I mean,
yes.
Or Android.
Correct.
Right.
Yes. Correct. Yes. This is also how we can execute on iOS. Yeah. Because on iOS we need to pre-compile everything, and this is the way it works.
That's sorcery. It's amazing, but it's sorcery. Okay, so that's that wasn't even. I mean, that's not even the star feature. I mean, a lot of I know companies have gone to market with just that mechanism there underpinning what they're doing. So you got this GraalVM thing. The big story is if you write your code, there's it's not 100% free. You might have to create a JSON file or two, but assuming you do that work, and it's not all that hard, especially if you have a framework like Spring. If you do that work, you get rocket speed startup, and much more importantly for me, since most apps are stateful and they live a long time, much less memory footprint.
Yeah, absolutely. And I mean, it's important to note that when you're using a framework like Spring, right? If you go to Spring Initializer and you create your first application, it works out of the box. It's like you don't need to do anything. It will compile to native.
Right.
And Spring Pet Clinic compiles to native without any problems. Right?
Yeah.
So it's really only in certain corner cases where you use a third-party library that is using like some very special features of the Java language, then there can be issues where you need a configuration file. But in most cases, you don't. And also, one has to say that sort of if that is the case, often it's a bit of a code smell of that third-party library to even do that in the first place, because certain aspects like dynamically generating bytecodes at runtime, yes, it is allowed, but it's not recommended if you don't absolutely have to.
Well, but to be fair, you also have to account for like I loaded a favicon.ico.
Right. You got to register the resources.
That's not a smell.
That's not a smell. That's a thing, but that's a thing that's like integrated in the Spring platform. I mean, if I register that as a Spring resource, it will work out of the box. But the more tricky things like generating bytecodes at runtime, or
that's definitely
or doing really crazy stuff in a static initializer, it's like it probably shouldn't happen. And the thing is, there like one of the benefits you get from doing this reflection registration is you get the security benefit from it.
Yeah.
Because if you look at the last 10, 20 years of vulnerabilities in the space, there have been a lot of vulnerabilities around serialization, deserialization. This is why it's like sort of deprecated nowadays.
I was just talking to Simon Ritter, and we like, if I reckon if we could go back and with a time machine, what would be the one thing it'd rip out from Java today? serialization.
Yeah.
Right?
And this is a form of reflection, right?
Yeah.
And the same thing is there have been a lot of issues with, something is reflectively accessed that shouldn't be accessed, or something is reflectively loaded that shouldn't be loaded. And with a native image, by specifying what is allowed, you can have those problems.
Yeah, you opt in, not opt out.
Yeah, you opt in. Yeah, correct. And that's from a security perspective. It's always better to opt in into such feature like that.
Right.
And that's why sort of the benefit, and I think it's an underappreciated benefit of using native image here, is you're forcing yourself to opt into these features, but by doing that, you're improving the security posture of your application.
I love it. And it's also a good discipline to have just as an exercise, even if you like just get to the point where you can use GraalVM, you're also going to have better code for it.
Yeah. And you will know what reflection I'm actually using,
Yeah.
right? Because these some of which SunMISC unsafe am I using, right? So SunMISC unsafe, for example, has been also a problem for us because yes, you put in some field offset into a static field, and then it needs to be updated because of different VM, etc. Right? And some of the frameworks or library specific that we are working with are doing that, right?
Yeah.
But it's another example where it's a good discipline, even as an application developer, to think about these things and be aware of these things, right? And we think that this is also something that offsets sort of the cost of having to document these aspects.
So okay, I'm a big fan. Obviously, I'm a big fan, and I keep telling people like it's not just that it makes my existing Java more performant, more memory efficient, more secure. Save the turtles also, but memory efficiency is great for turtles. They like that. It's not just that. It's also that it brings Java to new places that maybe you could have maybe made it work before, but it wasn't great, like CLIs or Kubernetes infrastructure or
or just serverless itself, right?
Yeah.
I mean. Many of our early adopters were companies doing serverless on AWS Lambda. The most notable is Disney Plus. Disney Plus had a huge article on why they're using GraalVM native image on AWS Lambda, because it saves them real money.
Yeah.
Because on AWS Lambda, the startup sequence is something you pay for. You pay a lot for. So in the sense, if you can do that pre-compilation startup sequence on your local development machine just once for your Lambda function, it's a big win.
Huge.
So this is something that really made Java competitive in the serverless space. And that's a good argument sort of when people at your company or say oh no, we need to use Go and Rust or something because it starts faster, it's more efficient, right? We are totally competitive with that. With GraalVM native image, you're competitive in startup and footprint with Go and Rust.
Yeah.
And at the same time, you keep leveraging a Java library ecosystem, including Spring library ecosystem. That's
28 years.
Yeah, that's
rich, mature library.
Yeah, that built up over decades, and that's just so much more mature than what you would have in Rust or Go, right?
Yeah.
So we really see this as something where the Java ecosystem just has another option to run things.
Yeah.
Where previously maybe people would be looking at other things because Java couldn't provide the same level of memory footprint and storage.
And now I also talk to people about this breathlessly because I'm a huge fan all the time. I talk about Loom gives you the Go concurrency Go routines, and I've got GraalVM for the small form factor images. And yes, by the way, caveat emptor, when you use GraalVM, you're getting a native image that is specific to the operating system. But just dollars to donuts, what platform you're running on? x86 Intel Linux, right? That's what most of the audience and most of the people out there are probably using. So what? Just it's fine. It took me about 5 minutes to get over the right once run anywhere thing being a little bit less than maybe it was. But in exchange, I get this incredible experience in production. Yeah, sign me up. Huge fan. Okay, so that's the today. That's yesterday even. All that stuff's yesterday.
That works as of today and as of yesterday even, yes.
Spring Boot 3.0 came out in November 2022. So we're 2023. It's almost November already as well. So it's been almost a year since Spring Boot 3 left the barn door. And obviously, the goal for us was to support AOT, not just for a new framework that was built from the ground up with it in mind, but for all the existing apps that could make their way to Spring Boot 3 if they can, because we're very good with backwards compatibility. So we want to make it so that every Spring app can be, if they wanted to put the little bit of effort in, they could get to GraalVM. Huge win. Lots of library ecosystem projects already out there, and I think this is the center of gravity is now such that all libraries, all open source projects will have to support this kind of stuff. Speaking of Amazon, their whole SDK supports GraalVM
Absolutely,
out of the box.
absolutely. All of the cloud providers,
Right.
actually, like the Google Cloud SDK, Amazon Cloud SDK, Microsoft Cloud SDK, all of them, and also the OCI Oracle Cloud SDK, of
Yeah.
course, do support native image, and
Why not?
because they know their customers want adoption, right?
And performance.
And we're not saying every Java app has to run on native image immediately
No.
today, but it's just as of today a really valid option for many apps
Yeah.
where it will run more efficient, and it's just an additional deployment option.
Yeah.
So it doesn't take away anything, and it's also important, like when you download Oracle GraalVM or GraalVM Community Edition, in both cases, you do get native image, but you also get a really good JIT compiler, and you can run your Java also in JIT mode if you want. And our JIT compiler actually outperforms the default JIT compiler on Hotspot in many cases. So you don't have to. It's not it's not like you need to choose one and forget the other.
No.
It's like you have the choice, and we give Java users here 2 choices of deployment. And I think that's just
huge.
This is huge and additive to the whole ecosystem.
And I couldn't agree more. So I'm all that to say it's here. This is not like this is not like the hypothetical, but let's talk about that. What can you tell us that without having to? What can I? You're a vice president. You could probably say things, but don't say things you can't say.
Of course. Yeah, no, I mean, we have like one of the upcoming things, of course, with GraalVM that we started to leak it a little bit at this DevOps conference, because there's just so many cool people here that we sort of want to share not only what we can do today, we also want to share with these people what we can do maybe tomorrow or a little bit later. And so the thing is, one of the aspects of native image is like, yeah, you don't have to do this recompilation every time the program starts. But currently, whenever you change a line in your program, and I saw it in your talk from a couple of days ago
with Alina.
Alina, yeah, you had to recompile the whole image over and over again, and
it wasn't
that bad.
30 seconds.
30 seconds, but still kind of annoying, and it's still sort of repetitive because in the end, the image will differ only in very minor parts, right? And this is why the major project the GraalVM engineering team is now starting is like something we call layered images, where it's layered native images where you build a layered base image for your Spring framework libraries and your Java base libraries, and then your application will be just a small image on top.
Yeah, the delta.
It's just the delta, which is typically very small. And this means the delta will also be able to be built very fast, so just a few seconds instead of 30. And you get sharing between applications. So if I have multiple Spring applications and I'm deploying it, I can use a shared Docker container base layer.
Yeah,
or
it's actually rather apt because they have layered Docker images.
Yeah, it's layered Docker images, so it fits very well together. Or in some scenarios, you might even be able to run them on the same machine, and that gets sort of the memory sharing between applications. And we think that this is like a real step function for native image, both for reducing build times and not making it so annoying when you have to rebuild the image all the time, but also for the memory sharing aspect, which is in the spirit of really trying to get the resource consumption down when you deploy apps.
So you could share the footprint of the base platform libraries across multiple images running on the same host, for example. You could just have it loaded into RAM once in the operating system, and then
so if you have 10 Spring applications, you're gonna load the Spring code just once. You can still have process isolation between that. This stuff from a security perspective can run independently, and you get the memory sharing. So we think that this could be huge, and that's why we think that's the biggest step function we can provide for native image as is today. And that's what we're working on. And we are happy that also the Spring team will work together with us on trying to make sure we define the right set of Spring-based images that make sense for Spring users, for example. And sort of
it would be like a static thing furnished by the internet, or could I compute my own, give my own?
You can compute your own on the ClassPass, right? But on the other hand, there might be some recommendation from the Spring team, or like there might be when I download Spring, there could be also something precompiled already, such that I don't have to compile my first,
like per jar.
Yeah. It could be pre-compiled before when I do Spring Initializer, for example. I could get the pre-compilation ready, so I don't have to do it even locally, right? So these are things we are thinking of into the future. Now the other aspect that
I know you can't give me an exact date, but my birthday is in January. Is it like
right?
Is it in time for my birthday, or is it after?
We're like it's not unlikely that we will have a prototype of this maybe by your birthday that can sort of demonstrate the concept. I think it will take a little bit longer to sort of make it production ready and go through the full test cycle and support Spring as a whole, right?
Yeah.
But to get it along, so we can kind of validate the concept and say we are confident that this is gonna work as we expected. We think we can do it in this time frame. Yeah.
Whatever, take your time. That's the coolest thing.
We try the fastest we can, and it's we have now a lot of users within information already. So which means we also need to make sure that whatever we do on the platform is not too disruptive to existing users. But it's still moving pretty fast. And the other aspect is on the performance aspect. So the big news in the last release was that for the first time, we could beat the cheat compiler configuration in all aspects, including peak throughput.
But that's only with PGO.
Correct. Yes. The way we do it is because the cheat compiler sort of has this advantage. It profiles the application. It gets sort of some information about the application before it compiles and can create better code there, right?
Right.
And in order to get there, what we did is we created this PGO, which is where you run a training workload. We gather the profiles from the training workload, and then we use that profile to build the app. And in this setup, we can actually beat the cheat compiler on peak throughput, which was the last metric where native image was kind of like, yeah, you get good startup, yeah, you get small memory, but peak throughput is still a little bit behind. No longer the case. Like we are at par or typically even better on peak throughput.
So the normal thing I hear is, and I've always said, the normal thing is, yes, it's got a smaller footprint than the JRE equivalent might, and yes, it starts up faster. But and there's always this dot. But then in terms of like transactions per second,
yes,
the contention was JRE would be a little bit better. And I've always said, even if that's true, it's so cheap to run these new native images. I can just scale two of them, and I'm now,
And also, like, even if that's true, it takes 1 million requests before you make up for the slow warm up startup. Because not only startup, it's also warm up time. But like,
legit.
We're like fast immediately on the first request and fast always in the same speed.
Right.
Very deterministic as well. So from a reliability perspective or deterministic performance, it's also an advantage. But apart from that, in the latest release, we're even faster after 1 million requests, and even after 10 million requests, you're faster. So there's no because there's some optimizations we can do better. Because first of all, we can spend whole world exactly. We can do optimizations across methods and looking at the whole program, where the cheat is typically looking at one method at a time. And like we can also spend more time in optimization because the cheat needs to sort of still produce the machine code relatively fast. And we can spend more time optimizing because it's on your development laptop or on your build server, right? And you can spend more CPU cycles there. And these are two major advantages we have over cheat. But the thing with this setup is, of course, if you need PGO and people need to define a training run, it's additional work. And what we figured is like, okay, many people don't really want to do the training run.
Right.
So that's why we started developing already about a year ago this machine learning based creation of.
Is this when my video gets like a lot more views?
Yeah, exactly. That's why we say AI, generative AI. It's generative AI because it's machine learning. It's statistics in the end.
Statistics, okay.
It's numbers, number crunching. But so what we do is we are making up the profile if you don't have a profile.
Okay. Thank you.
Exactly. So we kind of guess the profile, and you can think of it like, well, I give Josh, a Java program, and Josh will tell me, what is a hot path in the Java program, what is not a hot path.
Right.
And what will Josh do? Probably Josh will be like, yeah, there is some throw exception in this path, so okay, I will probably not. This is probably not hot, right? Or like there's a loop, it will be hot, right? So in this way, we are making up the profile, and we can get you a profile even without you interfering. And we want to build upon that. And in the future, we want to pre-record profiles for the Spring framework, such that the framework code, which is actually a very large part of the code you execute in, will be optimized much better even without the user providing any profile. And we think we can get there to beat the JIT compiler configuration even without requiring the training run. That's like the goal for the team, or the moonshot goal we have here. And this is an area we try to now work more on performance, on the performance when you do not have PGO.
So, okay, the PGO stuff is, I'm going to try it, obviously, but I had some questions and you answered them rather eloquently the other day around like, how much does that cost? Because the PGO stuff is in the commercial thing.
Well,
But
it's not the commercial thing. It's a free thing in the sense we have introduced in the last release Graal free terms and conditions license, and this allows free usage of what you download from us for both commercial and non-commercial purposes. And this means you can run it on your servers. It is not a fee. It's not open source. It's free as in free beer. It's not free as an open source software.
Sure.
But it's free. It does not cost a license. And the only thing that's prohibited by this license, if you are selling the binary that you create to somebody else, basically, if we give you something for free, we expect, and you give it then to somebody else, we expect you to also give it for free.
But if I'm running it on a service hosted on Oracle Cloud or any other place, my data center, Google, whatever, if I'm just running my Spring Boot app and I'm serving web pages and that's GraalVM native image, there's no cost there.
Yes, there is no cost. You can have a service running that's running on machines that you're renting from the cloud. And even if that service costs something, you can still use a GraalVM, Oracle GraalVM for free.
And that's so we're talking about the commercial, the I don't know what they call it, the non-open source one. There is an open source one. A lot of what we just talked about, it works with open source.
Yes.
And that's the community edition.
Yeah. There's the community edition as well that's built from open sources and available on an open source GPL license. There is other vendors also providing binaries for that. There's a binary from Red Hat. There's a binary from Bellsoft. So GraalVM is a multi-vendor project, a real multi-vendor project, which also means
Java, which is also
multi-vendor. Well, Java, which is also multi-vendor. But this means that like, as soon as more than one vendor is involved, at least like, if one vendor decides, I have no more interest in this technology, or I have some other reasons to change something, there's actually other vendors who will pick it up.
Right.
So this means there's much more like safety for users of GraalVM nowadays, that like, it's not one of the vendors can suddenly completely go crazy or change something dramatic, because there'll be other vendors actually stepping up in that case.
And that's really good to hear. I will say that it is, they make it very hard to love them, but Oracle have really impressed me with the way the Java projects and diaspora has been treated. It's still, everything is getting better.
Yeah.
It is just getting better.
Yeah, and we really try to give good technology. And it's,
and like you said, even the great technology is free.
Right.
Like,
yes.
And most of it is open source. And so it's just I'm super grateful. And if anybody was worried about Java in 2008 when it was acquired, I think those concerns have long since been put to bed.
Yeah, absolutely.
Yeah,
absolutely.
That's amazing. Anything else that you want to tell us that will not get me or you in trouble? Anything else you can share? Because if not, that's fine. We can call it good. But is there anything else that I missed?
I think that's good. I think there was a good conversation, Josh. I think we had I was a good opportunity to share some of the updates.
It's the coolest. I mean, everything you've just talked about is like mind-blowing to me. And if you told me 5 years ago or whatever, I know you've been doing this for 12 years, so it feels old hat. But for me, if you had said, "Hey, I can take this code that I'd written and do what you've enabled us to do," I would not believe you.
Yeah, and this is like, we are coming out of Oracle Labs, which is a research laboratory, right?
Are you the only project there? I don't know what else.
No, there is other projects as well. There is even MySQL Heatwave came out of the labs as well. It's now with the MySQL product group, but originally developed at the labs. There is some graph database related work done that's published there. So there's several labs projects, but like, for our mission, it's really important that we are labs, so which means our projects often take some risks. So they try to not just incrementally, change the status quo, but try to be a step function. So really, like, think about it, a little bit more from first principles on like what can we do to, in this case, get the most efficient way to run Java. And this then is reflected in the way we approach some of the projects and the way some of our products work. In that there's really a step function in what you can do with the stuff, and we will continue this type of mission forward to make sure we bring innovation to the space, and we move things in the right direction.
I love it. Can I bring you back in 6 months, whatever, and we can do
Absolutely.
a delta?
Absolutely, and we should next time. I would like to be on my keyboard. Maybe it's a screen sharing, so we can do some demo stuff.
Yes, that'd be so cool.
That would be excellent.
Well, so this actually worked well. This is a video, but I'm going to turn it into a podcast as well. So the screen share wouldn't have been great, but we can do another one.
All right, absolutely.
I'll invite you back sooner. In that case, we can do a demo.
Yeah.
Thank you, sir. And thanks for everybody that joined me. I appreciate that it's a weird hour, the weird time zone, but bye everybody. Have a good day.
Bye.